Hello everyone. On behalf of Indian National Trust for Art and Cultural Heritage, INTACH, and the INTACH Conservation Institute, I extend a very warm welcome to our distinguished speaker and everyone who has joined us for today's talk in the Conservation Insights 2020 lecture series. I'm Dr. Padma Rohila, Director ICI Delhi. Today is unfortunately the final lecture in collaboration with SUPSI University of Applied Sciences and Arts of Southern Switzerland. Again, I'm extremely grateful to Professor Jo and our team for organizing these lectures. Now to introduce our speaker for today, Dr. Marta Caroselli is a conservator restorer. She did her master's in conservation restoration at SUPSI University of Applied Science and Arts. And she's also a conservation scientist, having done a BSc from the University of Parma in Italy, and MSc at the University of Modena and Reggio Emilia in 2011. She specialized in the study of mortars, mural paintings, and stuccos. She later earned her PhD in 2015 at the University of Modena and Reggio Emilia with a thesis titled Mortar, Plaster, and Brick Dating, a case study of the Modena UNESCO site. She is now a lecturer and researcher with IMC, Institute of Materials and Constructions at SUPSI, where she, in addition to the teaching activities, also participates in research projects related to the characterization and the conservation of decorated architectural surfaces. The title of today's talk is Scientific Analysis for the Characterization of Historic Mortars and Stucco Works. Now, after a brief introduction to the raw materials used in our context, which is Northern Italy, Southern Switzerland, and the production technologies, the main scientific investigation techniques used for the study of mortars will be illustrated. We will learn today how to characterize a composite material such as historic mortars and how each methodology, that is chemical, mineralogical, petrographic, or physical, is not sufficient individually to determine a comprehensive characterizations. Of course, during the lecture, some examples of research in the field of mortars and stucco decorations and the results obtained will also be presented. Before I invite Marta to give her presentations, please ensure that all your microphones are on mute. Please type in your name, the organization email address in the chat box. We'd love to know who all are here. And also any questions that you all have also in the chat box. We'll take these up at the end of the lecture. So I now invite Marta to start her presentation. Dr. Marta Caroselli. Thank you, Marta.
Hello to everyone. Thank you very much, Padma, for the nice presentation. And as Padma well said, we are talking, I'm going direct to the topic because we have a lot of things to discuss together. And the topic is the application of the scientific analysis to the study of mortars. And in particular, also, we will have a focus on stucco artworks. I have structured the lectures first by giving a brief introduction to the raw material and the techniques, the production technologies, just because all of us, we come from maybe different geographical contexts, so maybe not every one of us have the same familiarity with the same material. So just to have a little insight of the different material that we are here in the North Italian and the Southern Switzerland area. Then we will see also the main scientific analysis that are normally used for the characterization and the study of mortars by giving many examples of research projects in order also to have a more practical and less theoretical lecture. So just to start with some theory, I will start by a definition, and the most important, according to me, is the definition of an artificial building material, which is a building material that should have the same or similar properties of that of a natural stone, but these characteristics were acquired through a technological process. And it's this characteristic that makes the mortar so interesting because the study of mortar have very important implication also in a different context, as for example, the archaeological one. So by the study of mortars, we can have information about the supply sources of raw materials, but also provenance study, for example, of binder or sand used for mortar production. We can also better understand how during the time were changed the commercial routes, and also interesting information about the skills and the technologies that the different population have during the century. By the studying of mortar, we can also have information about the decay phenomenon in order to understand the mechanisms that have caused this decay. And also we can have the correct information in order to design a good and compatible repair mortars for a good restoration work. One of the last experimental procedure applied to the study of mortar is also the absolute dating of structure, which was the topic of my PhD in the University of Modena. So at the very last part of the presentation, I will have a little focus about this topic. So let's start by saying that the mixing of very few and simple components is possible to obtain the large variety of artificial building material that were produced all over times. So having a very different applications such as mortar, but also painted plaster or three-dimensional decorated surfaces like, for example, stucco or multi-material, or also modern architecture. To study a mortar, there are several methodologies that can be applied, but in my opinion, the most important one, or especially the essential one for the starting point, is the study by the petrographic microscope. This is because in this way we can observe the whole aspect of the mortars and also understand if one element belongs to the binder or to the aggregate, also to understand the texture, so the porosity, and to have more information about the technological processes. To make it possible, the mortar sample should be prepared as thin section. The thin section preparation started with the sample is embedded in a resin in order to have it more strong. For having all these preparation techniques, then the sample is applied on a little glass surface, and then after the different cutting and polishing, we should obtain a thickness of the sample not more than 30 microns thickness. This is because we need to observe with the petrographical microscope and by using the transmitted light. So it's necessary that the light should pass through the sample. In fact, this is important because in this case, we can use all the mode of observation possible with the petrographic microscope. I'm not going into detail in the techniques, procedures, because we need much more time, but I will just give for the different techniques some insight about the information we can have with the different techniques. But I'm not going to give exact explanation about the technique itself. I would like to say that with the different light, it's possible to have complementary information about a mortar and a thin section. For example, in the first image, in the bottom left, you will see the image of a mortar with a reflective light, which is used mainly by chemists, by cement chemists, but also for the study of the polish section. So, for example, to observe the stratigraphy of a mural painting. And the same, the reflected light, but with the second image, this one, with the black field, is important to enhance the contrast of the image. The third image is the one with transmitted light. And in this case, we can observe the different aggregate binder percentage, the voids. As for example, in this case, you see this blue, which is the special preparation with the blue resin, which is better to identify the porosity, because the thing that you see in blue are the voids, so the porosity of the mortar. The last mode of observation is the one with the polarized light, and in this way we can also characterize the different minerals that are present as a sand or as a binder in the mortar. The binder component is the first thing that normally should be identified while studying a mortar. And an important classification of the binder is to understand if the binder is an air hardening one or a hydraulic binder. We can have different binder that can be used. For example, the air hardening one are gypsum and lime. Then we have the hydraulic ones, and we have also different possibility. In this case, we have the natural hydraulic lime, artificial hydraulic lime, natural cement, or Portland cement. But the other possibility is also to use an air hardening binder and have the hydraulic behavior with the addition of reactive additive, such as, for example, pozzolan material or cociopesto. We start from the first, the well-known lime cycle. So maybe all of you already have some information about this. So I'm going a little bit fast on this. I would like just to make the accent on the traditional process of production of a mortar. So the raw material is normally a limestone or marble, or in very few rare cases in this region, especially shells, because we need some calcium carbonate to be burned in order to start the process of production of the mortars. The burning process of lime takes place in these traditional kilns. And here you can see a reconstruction. So during a workshop, we try to use a traditional kilns in order to make the origins, the traditional process of lime production. Normally the temperature reached in these that need to prepare a mortar binder is around 700, 900 degrees. And here you can see that in this traditional kilns, there is the fire on the bottom on the kilns, and then all the stone put on top. When the last stone, so this one is completely burned, it means that the process is ended, and then we can stop the firing process and we can extract the material. The material that comes out after the burning is the quick lime, so the calcium oxide that need to be slaked. So mixed with the mix with water, in excess of water, we can obtain through isothermic process and the production of heating, we can obtain the calcium hydroxide, and so in excess of water, the lime putty, which is the things that I use for mixing and prepare the mortar. Then the lime was normally also better prepared by being mixing and also filtering in order to eliminate the unreactive part that can remain as residues in the lime putty. Another important process is the aging of the lime putty. As we know from also different historical sources, normally the more the lime putty is aged, the more we can obtain finer particles that can have a better workability and can produce a material with better characteristics. This traditional production process forms a binder which is not completely homogeneous, because as you see in this reconstruction of these kilns, we will have some stones which are very close to the fire, so in which and they are in the highest zone of temperature, with the highest temperature, and then we have some far stone from the fire. In this way, we obtain different material. For example, we can have the underburned particles. These particles are called, in general, binder-related particles. And we have the underburned, which are these particles that are far from the source of heating, and so they did not reach the correct temperature to being reactive, and they remain as witness of the original stones that was used for the lime production. This information is also useful because I can understand first which kind of stone was used, so for provenance, for example, study, but also to have more insight about the binder characterization, which is not always so easy with the microscope. On the other hand, we have the stone which are very close to the fire, and in this case, we can have the overburned particles. The overburned particles are particles that reach too much high temperature, and in this case, we arrive to the fusing or sintering of the lime. So when I found a lot of this kind of particles in a mortar, the information is that the production process was not so efficient because I have used a lot of energy, a lot of fuel, a lot of resources just to have a non-reactive particle. So it's not so efficient, the process in this case. I can have information by studying the overburned particles, information about the higher temperature reached in the kilns. The last type of particles I can find in a historical mortar is the lime lumps, which are the part of only binder that can be used for the study of the binder itself. Just to give you an example, to make it more clear, maybe, I can present this briefly, this case study about the castle of Carpi, which is a palace close to Modena. In this case, while the binder for the mortar production was taken by collecting by the builders river pebbles and cobbles from the rivers, for producing the most important plaster for the most important room of the castle was especially both a binder, a stone for the binder production, a globigerina limestone, we can see here as underburn residues, from the Veneto quarries. So for producing the most important part of the castle, some special binder were especially both for this purpose. A second example can be also another study I've taken with the University of Modena, in which we study the Vignola Castle, which is another castle in the province of Modena, which was built around the 11th, 16th century and is characterized by several different construction phases. For example, in the first phases, the one of the 11th century, the mortars were characterized of a high amount of these overburned particles, so testifying a not so efficient binder process of production. For the mortar of the other construction phases, for example, the 13th century or the 14th century addition, we can see that the number of overburned particles are really diminishing in numbers, and we have a higher presence of underburned particles. Also, in the 15th century addition, we have a higher use of binder with the mortar characterized with, by many lime lamps. We have also characterized two different modern mortars, one that belongs to a modern addition in the 18th century, in the 19th century, and other that were used during previous restoration works. So at the end, we could have different information, and for example, we could identify some structure of unknown age, which have this characteristic of having very much overburned particles, and so these unknown age phases were attributed to the very first phases of the building of the castle. Then we can go on by moving from the northern Italy to the southern Switzerland, in which the mortars are quite different because the raw material in this case is the raw material for binder production is the Dolomite stone that characterize the geology of the southern Switzerland. In these geological maps, this red and rose and pinkish part. The production of magnesium lime does not really follow a cycle, so it's not so easy as the one of the high calcium lime. First of all, it's important to say that the firing needs lower temperature, so not more around 500, 600 degrees, because the raw material is a double carbonate, both of calcium and magnesium, and this is the Dolomite. By firing this material, I will obtain two different components of the mortar. One part is the magnesium, which I will have the magnesium oxide by slaking the magnesium hydroxide, which is a mineral called brucite, which is very stable and has a low solubility. And this causes that in the mortar, the carbonation of this type of mortar is very long. So it can take also longer times. This causes that within the mortar, within a dolomitic mortar, I will have a large variety of different minerals. And this is very important to consider when, for example, one is studying, for example, the aging or the mechanism of decay of the different mortars. Because, for example, this large variety of minerals can cause different decay patterns. And here, for example, we will have portlandite, calcite, magnesite, and brucite, but also different hydrate magnesium carbonates. This depends very much on the reaction conditions. So the temperature with which the dolomite was fired, but also the humidity, the temperature in which the setting takes place, the technological process, and so on. One interesting case study, and I have done is this project, which is in the last part, which is called the Mortar Technology and Construction History at Müstair Monastery, which is a monastery in the eastern part of Switzerland, in the canton Grisons, that was founded according to the legend, already by Charlemagne in the 8th century. And it is a monastery that is a very long life, because this is still in use by nuns, so it's still a monastery. It has many modifications and many phases of construction. It was also deeply studied by archaeologists, both below and or below ground also with different archaeological excavation. And during all these studies, the archaeologists collected a very large amount of mortar samples. By studying all this sample, it is possible to have a lot of information concerning the evolution of the technology of the stone building technology during the century in this part of Switzerland. I would like to present this case in order to show you which aspect has a magnesium lime mortar. It is possible in some particular and lucky cases, I would say, to find this witness in lime lamps, this witness of hydromagnesite that not always are formed or are well visible, like in these cases. Because just to show you briefly, this is the hydromagnesite of the mineral shape, and this is what I see while cutting, so observing a thin section. So I can observe these radial and roundish shapes that testify the presence of magnesium components. If we are not so lucky to find these hydromagnesite component, we can also observe the underburned lime lamps and, for example, see if there are present of, as in these two cases I show you, if there are presence of dolostone. And this is another indicator of the use of a magnesium binder. The problem of the microscope, of the optical microscope itself, is that I can just resolve crystals with a dimension not bigger than 30 microns, which is the maximum thickness I can have for a thin section. So all the minerals that are that have a lower dimension, they cannot be resolved by the optical microscope. So I need, as for example, the binder, which has very microcrystalline components. So in this case, I can use, for example, higher magnification by means of a scanning electron microscope, in which I can have much more higher magnification, and also I can obtain the chemical analysis, for example, directly in the lime lamps. As I see here, the spectrum I can see that the presence both of calcium and magnesium, and also I can have a sort of quantification of the relative proportion of these two elements. Another possibility offered by scanning electron microscope is to obtain elemental maps in order to see how the different elemental composition is distributed within a thin section. For example, here we have the distribution of calcium in the left image, and we can say that we have a medium presence of calcium in the binder and a higher presence of calcium in the aggregate. On the contrary, in the right image, we see the distribution of magnesium, and in this case, we see that we have a medium quantity of magnesium within the binder and the absence of magnesium within the aggregate. So in this case, I can say that for producing this mortar, we'll use a magnesium lime binder, but the aggregate is mainly calcium carbonate. The other aerial hair hardening binder is which a large use in our region is gypsum. Also, gypsum is a sedimentary rock, similarly to the limestone, and it is found very spread all over Europe, especially, for example, in southern Spain, but also in Germany and in other countries. In Italy, we have also different gypsum outcrops in different regions, and also in Ticino there are some little outcrops. The gypsum process of production is took also place in these traditional kilns, in which also the temperature were very variable. For the production of gypsum, the temperature is lower than the one that is needed for the lime binder production. because normally we are the correct temperature is around 120, maximum 200 degrees. The gypsum is chemically a calcium sulfate with 2 molecules of water. With the process, with the firing, it's lost the crystal bounded water. So these 2 molecules of water were loose, and the anhydrite is obtained. So the calcium sulfate without water, and then with the addition of water, we have the setting process of the gypsum. It's very important to see in that with the setting process, the gypsum has this increase of volume because of the water uptake. And this is very important because also I can be aware of the use of aggregate, and we will see. The gypsum mortars also, similarly to the lime mortars, the traditional gypsum mortars contain also gypsum residues and impurities, and I can have information about the raw material used for the gypsum production. For example, in this case, I see, which is very common, within a residue of gypsum stone, some residues of calcite crystal, because they are as impurity in the gypsum stone, and they do not react at this lower temperature needed for the binder production of gypsum. On the other hand, I can also have some overburned particle of gypsum obtaining anhydrite, which has a very slow or reactive. So normally they can remain within the mortar. Also in this case, I can have information about the maximum temperature reached in the kilns. As I said before, the gypsum mortar are particular because they can be used with the addition of aggregate, but also without the addition of aggregate, as we see in this image in the right image, because of this increasing volume of gypsum, there is no need always to use the aggregate, and in some cases that can be also used for producing, for example, very fine plastering of inside the mortar. By using the scanning electron microscope, it's also possible studying the gypsum residues, so to see better and study the morphology of gypsum crystals, and also to have information about the elemental composition. The gypsum was widely used in Ticino for the production of stucco. In particular, if you have listened in the last week to the lecture of Giacinta Gian, she has already presented this project, the art and industry of Ticinese stuccatori. And we see that in this period, the techniques of production of a stucco normally follow a particular recipe. So in which the ground layer of the stucco was made of a mix of 2 binders. So to get the mixing together of lime and gypsum, together with a low presence of river sand aggregate. And the finishing layer of the stucco is made of only lime and marble powder, in order to give to the final aspect statue, an aspect similar to a marble statue. In order to characterize the recipe and to understand if there is the presence of gypsum in a mortar, it's possible with the observation with the microscope, but if the quantity of gypsum is not that much, or if we don't find any, for example, gypsum residues, which sometimes is also possible, we can use another technique as the FTIR, which is the infrared spectroscopy, with which I can have very easily the information about the presence of gypsum and lime, because both calcite and gypsum are very easily distinguishable. On the other hand, with this technique, it's not always possible to identify very well the magnesium component because of the overlaps of the two signals of calcite and calcium of magnesium carbonate. Another possibility for the identification of the mineral components of a stucco and the quantification of the quantity of gypsum and lime is the possibility to use the X-ray powder diffraction that can give information about the mineral phase content. For example, also using the quantitative refinement with the Rietveld method is possible also to have a quantification of the gypsum quantity and the lime quantity. But we should say that the mortar and the stucco are so composite material with many mineral phases because they have sands with different mineral component. So this quantification is not always straightforward. I think the best method for the quantification of the ratio lime to gypsum is to use the thermogravimetric analysis, which used the heating of the sample by observing the loss in weight at the different temperature. For example, if we see this pattern, we see that around 120 degrees, we have the weight loss of gypsum. Then we have the magnesium component here around 500 degrees, and then we have the lime and the calcite weight lost around 700 degrees. By making a simple proportion, we can have so the different amount of these components. We should say and underline the fact that these analyses should always be made together with the microscope analysis, because it's not possible to distinguish in this case the carbonate and gypsum component that belong to the binder or the ones that belong to the aggregate. Because I just make a powder, so I cannot distinguish anymore. I can have the other quantification, so the presence, for example, of an aggregate of calcium carbonate by making an analysis with a microscope. The other families of binder that can be used for the mortar production are the hydraulic binders. And we can go then from the pure limestone, which is completely air hardening, to the artificial Portland cement, which is an artificial material completely hydraulic. So for which the setting and hardening process are made in presence of water and not in presence of air. Between these two materials, we have also, how can I say, hybrid materials. So materials that have air hardening part and also hydraulic part. And this is special the case of the historic mortars. The more, here we see in this scheme, the more I have an impure and so a clay content within the raw material, the more I will obtain an hydraulic mortar. The more I have a clay content, the more I need to reach higher temperature within the kilns. So we go from the 700 degrees of an airline binder to the 1400 degrees that are needed for the firing of a Portland cement. The other big difference between these materials are that in the case of lime, I have the slaking process, so the mixing with water, while I cannot have it for the hydraulic mortar because the water will make the mortar reactive. So how can recognize if a mortar is more or less hydraulic? This is quite a complicated issue, especially in the case of historic mortars, in which maybe we have low hydraulic component. Sometimes this is reached because of impure limestones used for the lime production, so with a low clay content. And this is possible to be observed by studying the binder-related particles. If I saw that the binder-related particles, sorry,
sì, adesso aspetta.
Okay. If I saw some binder-related particle with hydraulic properties, so impure limestone, so a high content of clay, I can infer that probably the binder will be hydraulic. Normally, also the cement in the very first phases of production of the cement, as for example the Roman cement, which is a natural cement, which is a cement produced by a raw material with a high content of clay, because of the old process of production, I will have some residues of these clinkers within the mortar matrix. And this can indicate, by analyzing the mineral within it, I can say if this is an old cement, a natural cement, or a Portland cement. Another possibility is also to have higher magnification and to study these binder-related particles, so this clinker, with the scanning electron microscope. And also in this case, I can distinguish, for example, the calcium silicate dehydrate from the aluminate and the iron part of the clinker. The same can be done for a Portland cement. The higher temperature of the kilns make the production of 3 calcium silicates. So I can distinguish, by studying this clinker, I can distinguish an old cement from a natural cement. And these are some images described of cement mortar. You can see there are not so much differences. So it is very important to study, for example, with scanning electron microscope, these leader residues. As for example, in this image, you can see here these little black spots. So I need higher magnification or another mode of visualization, for example, the reflective mode in bright field. As in this case, I can recognize these clinker residues and characterize also a cement mortar. The other possibility to obtain an hydraulic mortar is the addition of reactive aggregates, such, for example, pozzolan or cocciapesto material, and these are the material I can easily characterize, because this material are easily also distinguishable by the microscope. It is very important to see that these materials have reacted with the binder. So normally this material should be dissolved within the binder, and I should see the reaction edge between the aggregate or the binder. Another possibility I have with the microscope or the scanning electron microscope to study the organic addition, such as, for example, wood or straw or charcoal, for example, or also fibers, for example, in the case of Stucco. Is more complicated the study of organic additions, such as additive, as for example, protein or fat component, for which we need some special characterization, which I'm not going into details today. With the microscope is also possible to understand and study the mechanism of decay. As for example, here we can see that this mortar with very large pores have some processes of dissolution, and here a higher magnification of a recrystallization of the calcitic binder. This is because an air lime is not made for being in long contact with water, because also the calcium carbonate has low, but it has some solubility. So the binder can be taken away, so increasing the porosity, and also we can have secondary crystallization of calcite around the pores. It's also possible to observe a secondary process of sulfation, for example, the transformation of the calcium carbonate in calcium sulfate because of sulfation of and weathering process due to aggressive environment. The other part of the mortar, so a part of the binder, we can also study in detail the aggregate. And the study of aggregate is mainly made by microscopy, because it is easily easily observable. And normally, for the production of mortars, the aggregate is made by using the sand taken from a river. The grain size of a sand is by definition, is from 63 microns to 2 millimeters, and we can have fine, very fine, medium or coarse sand. And under the 63 microns, we have the finer part of the sediment, mainly silt or clay materials. The aggregate can be used as it is, or can be also sieved. So selecting a special grain size for the production of mortar. For example, for the production of stucco, the finishing layer was made with finer particle size of the aggregate, and normally this is also done for the plaster, so for preparing some material to be painted on. The selection of the aggregate can be also classified, saying if it has a good sorting or a poor sorting. And here, for example, you can see a mortar with a good sorting, so in which the dimension of the aggregate is well distributed, or another type in which we can observe a poor sorting, and they have very fine particle or very large ones. Another interesting feature that I can observe of the aggregate is the sphericity and the roundness. In order to understand if the aggregate was used by taking a river sand, so normally with high roundness and sphericity, or if it was crushed from, for example, quarried material, and in this case I will see a sharp edge, as for example, for taking the same example of the stucco, the finishing is made of marble powder, of crushed marble powder. I can also observe the distribution of the aggregate, if it is well distributed or not, and also if the aggregate is oriented. It is normally when, for example, preparing a plaster, if for preparing a plaster, normally the builders used to push and to work a lot on the surface. And in this case, the most elongated aggregate will have a preferential orientation. It is also very important and possible by the microscopic study to identify the composition of the mortar, of the aggregate, in order to understand from which source it was taken. For example, in this case, we have effusive stone, or mainly silicatic, or mainly marble powder. So this can indicate the raw material sources for sand. And to study the texture of the mortar, for example, the percentage between the aggregate, the binder, the porosity, the shape of the porosity, and also the presence of binder-related particles, it is possible to associate to the petrographic image to the image analysis. And through this particular software and through algorithms, it's possible to quantify and obtain textural graphs concerning the different mortars. And have parameters such as the distribution of the aggregate, the binder-aggregate ratio, the quantity of porosity, and so on. One example of this was the topic of my PhD thesis, which was the UNESCO site of Modena, the cathedral and the Ghirlandina Tower, in which were recognized 3 different construction phases, and these were well distinguishable because in these different construction phases, different sands were used with different mineralogical components. So the identification of the sand provenance together with the textural parameters of the different mortar of the different phases of construction, it was possible to identify the different parts and the different authors that have worked on this important UNESCO site. Another possibility to have more information and to have the absolute dating about the exact moment of construction of a building is the possibility to date the mortar binder by means of radiocarbon. And this is possible not only by dating the charcoal component, so the organic component, but the carbon, which is it is possible to date the carbon which is absorbed while the mortar is setting. So the exact moment of construction of the building. This is in principle very easy, but in reality it required a very complex preparation in order to avoid contaminants of what it is called dead carbon, as for example, the carbon belonging to the aggregate that should be eliminated. To do it, there are mainly 2 different techniques used by different labs all over Europe, and they can be used both for eliminate the contamination, and so to obtain a reliable dating at the end. For example, in my PhD thesis, it was possible to have more information about the construction phases by applying the radiocarbon dating together with another dating technique, which is the optical stimulated luminescence. The last topic I would like to touch concerning the mortar, only because it's very, very important, is the study of the mortar for producing a repair mortar. We should think about that a restoration mortar, to have a good restoration mortar is not the mortar that will last forever, but is a mortar that has the purpose of making the original mortar last for the longer time possible. So it is very important to think about the reversibility. So this mortar should be possible to be removed in case I would like to change or to or maybe if the circumstances around change, or if the restoration mortar decay with time. So the most important feature to think about is the affinity and compatibility of the new mortar with the original substrate. There are mainly three steps for the design of a restoration mortar. Firstly, the characterization of the original one, and we have talked about it already. But then we should determine the desired performance criteria and requirement. And this is, for example, it is important to think about some conceptual requirement, as for example, as I've said, the reversibility, but also retractability or compatibility, or long-term durability of the new mortar, how much it should last or not. And also the mortar should be designed considering the function that is needed in the specific case by case. So if it's a bedding mortar or a repair for a plaster, or if it is a mortar for a grouting, so injection grouting, and so on. After this study, it is important to prepare and use some reintegration mortar by make some mix design with different typology of mortar by choosing the materials, so the binder, the aggregate, being compatible with the original one, and also considering the relative quantities. It is also important to test different mixing procedure and also application methods. So to conclude this long talk, I would like just to make some point that we have seen that through the study of mortar, we could characterize the change in time of production techniques for mortar preparation. The study of the aggregate and the binder composition represent one important tool for distinguish the construction phases, or also for the attribution to a specific author of some artworks. Also, the textural parameters are a tool for recognition and distinguish of the construction phase chronology, and they can be applied to indirectly date the building phase of unknown age. The application of the absolute dating of mortar by means, for example, of radiocarbon represents a great advantage and an important improvement for historic reconstruction. And finally, the study of ancient mortars is also a fundamental step for the design of a correct and compatible repair and restoration works. With this, I have finished. I thank you all for the attention, and I'm open for questions if you have some. Thank you very much.
Thank you. Thank you very much. I think that was a very interesting talk. And yes, we have questions. So if I can start. First question is, for true frescoes, can you hear me? For true frescoes, which lime would you advise, would you think was used with or without magnesium? And if the prepared lime had dried up, was it used again? Can it be used again for a true fresco? That's the question.
If I understand correctly, the question is about if the magnesium lime can be used for fresco production.
Yes. Is it preferred for fresco? And if it dries up, can it be used again?
No, the mortar can never be reused, because once the hardening process is made, the material cannot be reused, but it's possible if the production of fresco or mural painting or plaster, also with the dolomitic raw materials. This is very possible also because in some part, as especially in the southern Switzerland or in northern Italy, is the only material which is present. So people, skilled workers, has learned how to use also this material for the production of mural painting.
Okay, thank you. Once lime mortar is prepared, this is again a question, and stored, how long can it be stored and used as a mortar? Lime mortar prepared. Also, what is the life period of surface plaster?
So concerning the first question, the binder can be aged and can stay also. For example, lime putty can stay for longer. The longer it ages, the better it is. But if the mortar is prepared, then it's better to use as soon as possible, because the contact with air would make it reacting, so make it hardened.
Okay, thank you. A question from Mr. Aditya Kant. Could you explain the percentage of carbon in EDX graph? Did you sputter your sample for conduction? Was the sputtering done for conduction?
No, I don't understand, sorry.
Okay, it's the percentage of carbon in EDX graph. One of your slides.
Okay.
And also, was sputtering done for that particular sample? The process was sputtering for conduction.
So the carbon, if the question is about the scanning electron microscope, the carbon is normally not very well counted with the scanning electron microscope, also because the carbon is present as in the resin, as the main component of the resin, which is used for embedding the mortar sample. So the carbon percentage is not significant in this case to be analyzed with scanning electron microscope. Are more significant to analyze, for example, the sulfate component, or the calcium component, or the magnesium component, or also to characterize, for example, the aggregate, so the elemental composition of the sand.
Okay, thank you. Another question is, the transformation of gypsum dihydrate to anhydrate is temperature dependent. So yes. Does temperature in that area, does it reach to a level where anhydrate formation is possible? And he's saying you did mean anhydrate and not anhydrite.
Yes, if the temperature of burning, of firing of the gypsum, there is a very variable range of temperature. Depending on the temperature, you can obtain different building material. For example, if you have high temperature gypsum, you will have a material which will be more resistant, for example, in the outside condition, but at the same time with a slowly time of reaction. So it will slowly react to form the hydrate component. And this was very well known by the old workers, because they can very much preparing the binder according to the use they should, the mortar was prepared for.
Okay. A question from Chiara Pasian. How do you distinguish in a mortar residue of Portland cement versus natural cement?
Yes, this can be recognized because of the mineral phases that are formed. I didn't go too much in detail on this because it is a completely another chapter. But depending on the temperature reached in the kilns, normally the natural cement is burned around 1,200, while a Portland cement should reach higher temperature, so 1,400. And these produce different mineral phases within the clinker. For example, 3-calcium silicate is only present for a Portland cement, while a D-calcium silicate is present both in Portland cement and in natural cement. So by studying the clinker, is possible going in detail and in deep with this analysis to understand the raw material, and then also the type of material, if it was a forced cement or a natural one. And also, just to, I don't remember if I have said it, but the very recent cement are they are not made by traditional process, so these residues are not present. So I can distinguish, for example, a cement of restoration mortar because we do not have any clinker residues.
Thank you. What is the name of the image classification software used?
There is a free software that can be for download for free, which is named IMAGE-J. And it is used for all type of image analysis and should be adapted for the analysis of mortar. It is also used for other counting. It permits to calculate the areas in one image. Okay.
Can you spell it out for us, Marta? Can you please spell it?
Image, so I-M-A-G-A, no, sorry, E and J.
Okay, image J.
Yes.
Okay.
And this is a free one. There are also some software that should be paid. Okay. Maybe more user-friendly, but with this is possible also with the free version.
Okay, then we have, can we use lime water in consolidation of wall paintings? Any references of lime water used in consolidation of wall paintings?
Allora, yes, the lime water can be used even if it's not the best solution in most of the cases, because the power of consolidation is quite low because of the low solubility of the calcium hydroxide. So for consolidated wall painting, you would need to introduce to the masonry a lot of water and many lighters. And so this is not always compatible with the condition of the wall painting, because normally if a masonry or a plaster is already decayed, I have the problem of salt, and so introducing all this water should cause an increase of the problem more than the consolidation effect that I will have, which is very much compatible, but at the same time it is a low power of consolidation.
Okay, thank you. The next question is Joshua Hill. It's from Joshua Hill. He wants to know what strategies can be used to mitigate against sampling bias in mortar research. For example, if there are large aggregates as part of the mortar. For example, in the image analysis you showed, some of the aggregates formed a large part of that image and would have implications for the binder aggregate ratio that is to be determined.
Yes, this is a very good question, because this is one of the, I didn't said it, but it's this is one of the problem is the selection, the first selection of representative sample. Normally the scale of I think section of a mortar sample is 2 centimeters per 3 centimeters. And so we have very small surface to be studied. And in the case we have big aggregates, this can be a great problem, because I will have very small information. So it is very important first to start with other investigation. For example, the visual observation. It is very important, and the scientists are supported in this work by the restorers, because only a very a deep knowledge about the case study can indicate which is the best point of sampling. For example, in order to avoid a restoration mortar or a not original one. So this is very important to that the sampling part is the very last part of the diagnostic strategy. And before, it is very important to make all the also non-invasive and visual observation with other technique. Concerning the second part of the question, normally the image analysis is made on 3 images of one thin section, and then at the end is calculated the average of the values, calculating on 3 thin section, on 3 images of the same thin section. Or it is also possible to have a scan, a complete scan of an entire thin section, and have the quantification on the entire thin section. And in this case, the results are more reliable.
I think people are Marta, would it be possible if you're comfortable to share your email ID? Because I believe people want to get in touch with your thing. If it's not a problem.
Yes, of course. Probably I forgot to put my name at the end of the presentation, and maybe on, I don't know if on the flyer there is, but my email address is Marta.
Or if you could just type it in that chat box, maybe people can just,
yes,
you know, if it's not an issue. Thank you.
Here we are.
Thank you. Question, are there any links to check guidelines for sampling? Guidelines for sampling, yeah. Is there
yes, there are some, yes, there are some European norm concerning the sampling of cultural heritage material, and that can be followed. There are the Italian ones, or also the European ones. We normally follow for the sampling
so these
strategy.
Are published? Are these publications that one can?
They can be. It should be paid for having. It's not publicly available. Okay. But there are maybe other publications that explain it, maybe not the complete norm, but in a different publication, there are some explaining of the sampling strategies. If someone is interested in it, I have different publication, and if they write to me, I can send it the contact.
Thank you. Thank you very much. Any other questions? I don't see any getting typed in. Any questions? I think that's a lot of thank yous, I think, in the chat box. So I think, thank you very much, Marta. I think today's lecture was very, very enlightening. A lot of mortar testing happening, I think, now, knowing this. And getting flooded by email requests, hopefully. So that will be great. Thank you so much, Marta, Patrizia, Francesca, Jacinta, everyone who's taken the time out. We really enjoyed the series, and hopefully, as we discussed, we'll probably get in touch and discuss more.
Absolutely.
Just who is listening, the next lecture series starts on the 29th of June. We have Jeffrey Wallace, who will be talking about the